In this video, you will learn about square roots of variable expressions. So what we are doing is we're working with square roots, but now we have variables incorporated. So for example, here we have the square root of 169x squared, and you are told to simplify. Now to simplify, there are different ways you can do this. Using this first method, what I can do is I can separate this as a product of two different radicals. I can write this as the square root of 169 times the square root of x squared. So I broke this up into two radicals, and the square root of 169 is going to be 13, and then the square root of x squared, the squared and the square root undo each other, and that gives me an x. If you didn't see that, you could do the square root of x times x and realize that there are two x's here, and pull out one x because there's one group. So that gives me 1x on the outside, nothing on the inside. Either way, my answer would be 13 times x. Now using method 2, I take the same radical, and what I can do is break apart the 169 as a product of 13 times 13. Then x squared, we have x times x. So from this point, I see that we have two 13s. So I can pull out one 13, and I'm left with no 13s inside. And here are two x's, so I can pull out one x, and I'm left with nothing on the inside. So again, my final answer would be 13 times x. Now for most of these, there are different ways you can think of this, and as long as you get the correct answer, it doesn't matter which method you choose to solve. Example 2, we have the square root of 36x to the fourth power. Using the first method, I can separate into two different radicals, the square root of 36 times the square root of x to the fourth power. Now the square root of 36 we know to be 6, and then here, the square root of x to the fourth power, we can think of x to the fourth as x squared squared. So if you have x squared squared, the squared and the square root undo each other, and I'm left with simply an x squared left over. So that is one way you can think through this problem. The second way is you can break down the 36 as a product of 6 times 6, and then x to the fourth power, you have four x's multiplied together. And here we see two 6's, so I can pull out one 6. Here I see two x's, so I can pull out one x. And then here's another group of x's, so I can pull out another x. And I'm left with nothing on the inside, so that gives me 6 times x on the outside, which is 6 times x squared. So notice again, we have the same solution using either method. Here's another example where we are told to simplify the square root of x squared minus 6x plus 9. Now this one, I want to factor x squared minus 6x plus 9. If I factor, I'm going to get x times x to get x squared, and then if we have minus 3 and minus 3, that would multiply to give me a positive 9, and would add to give me negative 6x. So I can think of this as x minus 3 times x minus 3, or x minus 3 squared. So here I have a square root of a square. The square and the square root undo each other, and I'm left with x minus 3 left over. Here's another example where we have 12 times x to the fifth power. What I can do is I can break down the 12 as a product of 4 times 3, and 4 is 2 times 2, so 12 would be 2 times 2 times 3. And then we have 5 x's. Alright, so you don't need to write out all of this, but your thought process should be kind of like this, where we look for groups of two things. So here we see 2's, x's, and then another set of x's. So I can pull out a 2, an x, and another x. So now we're left with, on the inside, 3 times x. So on the outside, I have 2 times x squared. On the inside, we have 3 times x. So right here is my simplified form of the square root of 12 times x to the fifth power. Next, we're going to work with equations. So here's an equation where you have x squared equals 25. Now to solve equations with a square in them, what I can do is get rid of the square by taking the square root of both sides. So here, for example, I can take the square root of the left and the right side. When I do that on the left side, the square root of x squared, the square and the square root undo each other. That leaves me with an x over here. The right side, the square root of 25, is going to be 5, but we actually have two answers. It could be a positive 5 or a negative 5, because the square root of 25 is saying what squared gives me 25. Well, 5 squared is 25, but also negative 5 squared would also equal positive 25. So I have two answers. One is a positive 5, one is a negative 5. So I can write it with this plus or minus sign like you see right here, or as two separate answers where you have 5 and negative 5. Now this method works because we have the square on one side and then the number on the other side. So if you had like x squared equals 49, for example, you can take the square root of both sides right away to get x equals plus or minus 7. If the squared term and the number are not on opposite sides, I need to make sure that they're on opposite sides before I take the square root. So basically, I need to make sure that this x squared term is isolated first before I take the square root. So for example, here we see x squared minus 36 equals 0. At this point right here, I cannot take the square root of both sides because the squared term is not isolated. So what to do is I add 36 to both sides to bring this over to the right side. That now gives me x squared equals 36. And now at this point, because we have the x squared term by itself, I can take the square root of both sides. When I do that on the left side, the square and the square root undo each other, and I'm left with an x over here. And then on the other side, I have the square root of 36, which would be either a positive or a negative 6. I can write it like this, or I can write it like positive 6 and then negative 6 with two different answers. So either way, the plus or minus or just writing it out separately, both mean the same thing. So this is one method of solving the equation, but I do want to point out that there's a second method. The second method is not using the same process, but instead is using factoring. So factoring would work as well, where you could recognize this as a difference of squares and can factor to be x minus 6 times x plus 6. Once you factor, you can set each part equal to 0. So either x minus 6 equals 0 or x plus 6 equals 0. I can solve each one. Here we have x equals 6. Here we'd have x equals negative 6. So either way, we get the same solution. So whichever method is easiest for you, you can use either method. But in this lesson, we're working specifically with method 1 right here. So let's take a look at one more example. Here we have 16x squared minus 25 equals 0. So using method 1, I need to isolate the x squared term. So I do that by adding 25 to both sides, and that gives me 16x squared equals 25. Now at this point, you could take the square root of both sides right now, or you could totally isolate x squared by dividing both sides by 16. Either is fine, but we'll do it this way for method 1, where now we have x squared on the left and then 25 over 16 on the right. So now that we've isolated the x squared term, we can now take the square root of both sides. So when I take the square root of the left side, this now becomes an x, and then on the right side, we have a positive or negative square root of 25 over 16. Now to take the square root of a fraction, we can write this as the square root of 25 over the square root of 16, which would equal 5 over 4. So here x would equal a positive or negative 5 over 4. And again, we could have used factoring to solve this as well. And we could have also, right at this point right here, when you had the 16x squared equals 25, if you wanted to, you could have taken the square root at this point as well. So there's different ways you can solve the same problem. As long as you are following correct procedure, it doesn't matter how you get the correct answer. And that concludes our lesson for today. We will see you next time.